Okay, students, this is lesson 3, Alkenes, Alkynes, Cyclic Hydrocarbons. So we're going to identify and describe significant organic compounds in daily life. We'll name and draw the structural, condensed, and line diagrams for the ones mentioned above. And we're going to compare some boiling points and a little bit of solubility. Alright, so talking about alkenes. Now alkenes have double bonds, and they have the formula CnH to the 2n. So there's an alkane, C2H6. There is an alkene with a double bond, C2H4. Alright, so we have this double bond, and we call the double bond a functional group. Here's what a functional group is. It's a characteristic arrangement of atoms or bonds that determines the most important chemical and physical characteristics of the molecule. So I say it's kind of like the fingerprint. An alkene identifies itself as an alkene as opposed to an alkane that only has single bonds. Okay, double bonds make this compound unsaturated. It is not full of hydrogens. And they form a trigonal planar shape. So that would look like this. So you can see that we have this shape here, and there it is again on both sides. Okay? Alright, good. Alright, how do we name these things? Now the parent molecule is the longest carbon chain, so you know how to find a parent, find the longest continuous chain that has the double bond. Now, in other words, branches will not have double bonds in our course. So, here's our longest continuous chain right here. Right? If you ever have a double bond in a branch, I'm saying that won't be a branch in our course. The double bond will be the parent. You have to number the double bond so that it gets the lowest number. Now you might say to yourself, wait a minute, Mr. Gibbings, you're incorrect. You told us that the branches get the lowest possible number in the last lesson. That's true. However, when we get to this point, we have some priorities that need to take place. So I would number this compound this way, 1, 2, 3, 4, 5. And this double bond would be carbon number 2 or 3. We'll pick the lowest number, carbon number 2. Here's our rules. If you have both double or triple bonds and branches in the same compound, the double or triple bond gets priority. Okay? So in this compound, we've got a branch here, and we've got a double bond here. Well, we're not going to number it 1, 2, 3, because that would give the branch priority. We need to give the double bond the priority. 1, 2, 3, 4, 5. Okay, so that gets the priority, and then the branch. Alright, then there is an alphabetical priority, which could happen in this situation. Look at this compound. There's the parent, 1, 2, 3. So that branch is connected to 1, 2, 3. This branch, 1, 2, 3. This branch is also connected to a 3. So we have to go by alphabetical priority. Okay, so this is a methyl branch. This is an ethyl branch. The ethyl alphabetically gets priority. So we would number it 1, 2, 3, 4, 5, 6, 7, 8. Okay? Alright, let's move on. Now the suffix on these is ene. If it's an alkene, it ends with ene. Pentene. Use a number in front of the ene to identify the location of the double bond. Okay, so watch this. Because the double bond is attached to carbon number 2, we name it this way. Pent-2-ene. It's a pentene with a double bond attached to carbon number 2. Alright, and then name and list any branches. Well, we have a methyl branch, and so finally the parent's name is 4-methyl pent-2-ene. Okay, so let's take a look at these. How would you name this one? Well, it's got 2 carbons and it's got a double bond. So you're right, it would be eth1-ene. Now, because it doesn't not matter which way you number this, you could number this 1 here, 2 here, or you could go 1, 2. It's going to be the same either way. It's going to be eth1ene, so we can just call it ethene. Either way, you're fine. How would you name this one? Give that a try. Pause me if you don't want to know right away. All right, here we go. Here's the answer. This is prop1ene. I've got 3 carbons, double bond attached to the first carbon. And, oddly enough, look at this. If I was to flip this around, we would number it 1, 2, 3. It would still be prop1ene. So you could just call this propene. Now, when you get to this one, the double bond doesn't have to be here. You could have moved the double bond here. And because of that, now the number is important, because there's 2 combinations, not just 1 combination. So, how would you name that? You're right, that's but1ene. Now, how would you name this one? Yep, that's right, but2ene. Okay, how would you name this one? Give that a try. If you don't want to know right away, just pause me. Alright, well, take a look. We'd number it 1, 2, 3, 4. There's my parent, but1ene, with a methyl branch, 3-methyl, but1ene. Alright, now try this one. And here's the answer. You ready? 5-methyl, because I got a methyl branch there. Hex, I've got 6. Carbon number 2 has the double bond. 5-methyl hex2ene. Great. Now, a whole other category of compounds called alkynes. Now, these have the formula CnH to the 2n minus 2 this time. Now, there's our alkane, C2H6. And there's our alkyne. It's got 4 less hydrogens. So Cn, remember n is the number of carbons, H to the 2n, 2 times 2 is 4, minus 2 is 2. Formula is C2H2. These contain a triple bond. They are also unsaturated. And these have a linear shape. So you can see the 3 different shapes. There's that shape. We talked about the trigonal planar. And now these are linear. You see the 3 bonds there? 1, 2, 3. This forms a line. All right. How do we name these? It's exactly the same as the rules for alkenes, except for we end up with a suffix yne, or alkyne. All right. So let's take a look at some examples. So here you can see the structural, the condensed structural, and the line diagrams. All right, what would you name that one? You are correct. That would be eth1ine, because there's no other possible way this could be numbered. It would be ethine. All right, I'm sure you could do this one real quick too. but1ine. We move the triple bond from here into the middle. And now we've got but2ine. All right, how would you name that one? Give that a try. All right. Good. We've got a parent. We've got a branch. 3-methyl but1ine. Now, how would you draw this one? Not name it. How would you draw that one? Well, I got a little video that'll show you. Why don't you give it a try, and then push pause, and then unpause me, and you'll see how we draw.
Go ahead.
Okay, so we want to draw dimethyl but1ine. So the first thing is, let's just identify the parent, but1ine. So I'm going to draw 4 carbons. Let's say that's carbon number 1. Attached to carbon number 1 is the triple bond. Now, remember, you can only have 4 bonds around a carbon. 1, 2, 3, 4. 1, 2, 3, 4. There. So there's but1ine. And now I've got dimethyl. I've got 2 methyls. The only place they could possibly go is right there. I don't need the numbers 3, 3 dash dimethyl, because That's the only place they can go. So the name is dimethylbutanine. There's my two methyls. There's my triple bond on carbon 1, dimethylbutane. That's it. Okay, now let's talk about some physical properties of alkanes, alkenes, and alkynes. First of all, boiling points increase as the carbon content increases. Okay, what does that mean? Well, let's take C3H8. Now the carbon content means there's 3 carbons in there, right? So we know what C3H8 is. That's propane. There's a propane bottle. There's what it looks like. Here's the structural diagram. All right. Now, we're also going to talk about the state of matter here at standard ambient temperature and pressure, which is at 25 degrees Celsius. It becomes more dense as the molecules increase in size. Okay, so when we've got 1 to 4 carbon atoms, we have a low boiling point, and the state of matter is it's a gas. Okay, all right, so watch this. Boiling point of propane is minus 42. That's when it boils. So it heats up to a balmy minus 42 and it starts boiling. And then by the time it gets up to like 25 degrees Celsius, it's a gas, right? All right, so boiling point boils at minus 42. All right, now let's increase the carbon content. Let's add carbons. So let's say we've got C5H12. Now we add a couple of carbons onto propane. So here's propane, 1, 2, 3. We add a 4th and a 5th carbon. What happens to the boiling point? Well, the boiling point, it boils at plus 36. So it doesn't boil till way up here. So it's actually a liquid at 25 degrees Celsius. Okay? All right, let's add a bunch more carbons. So we got something like this, C25H52. Now this is a little misleading. Paraffin wax is made up of carbon chains. Some of them are 25, some of them are 31. So anyway, we picked C25H52. Now that's what paraffin wax should look like. Great big long hydrocarbon. And there's a candle, right? Or paraffin wax. It's the same thing in candles. All right. This is over 18 carbons, but less than 26. Boiling point 370 degrees is when it boils. Not when it melts, when it boils. So that's way off the chart there. All right. Now they say these are semi-solids. I don't want to get into that. Greases and waxes, and then when they solidify even further, then add a few more carbons. So remember, these are mixtures of these long chains, but anyway, we don't have to worry about that. Finally, let's go to these. This is annoying. Alkenes are slightly lower than alkanes. Alkynes are slightly higher than alkanes. What does that mean? Okay, take a look at this. If you had an alkane, so ethane with 2 carbons in it, it boils at minus 89. Now, if we just keep with the same compound, an eth compound, but we have a double bond, the boiling point drops a little, and with a triple bond, it goes up a little. Anyway, so that's frustrating. I have to realize that, but that's the rules. Okay, let's keep going. Now, solubility in water is nil. These do not dissolve in water because they're nonpolar. So if you poured gasoline into water, this is what you'd see. It wouldn't mix. So water is polar and octane is nonpolar. And remember those rules. Like dissolves like. If they were both polar, they would mix. But because one's nonpolar and one's polar, they do not mix. They do not dissolve into each other. And that's why if you had a car in an accident, and this looks like a flooding situation, you can see the gasoline and oil, that all just sort of floats on top of the water there. Okay, let's talk about common alkanes, alkenes, and alkynes. Okay, so a very common one is methane. This is natural gas. Now you know where natural gas is in your house, I hope. some of you may have stoves that use natural gas burners that look like that, as opposed to those coiled elements that you see. Down in your basement, you have a water tank and you have a furnace. That's what the inside of those look like. There's little fires going under there, and the fuel in our area that runs those is methane, or natural gas. So you will see inside those, if you were to look, little fires burning in there, and that's natural gas. That's why you need chimneys, because there's fire in there. Okay, propane is used. You know where that is used. It's used in barbecues. It's used for fuel on camp stoves. You've seen torches that look like this that have propane in them for heating things up in the shop. Vehicles can run on propane. I used to have a friend that had a truck with a propane tank in the back when I was in high school. Check this out. In some places, they don't have natural gas to heat their house. They have propane. I remember my grandma had a big propane tank in her backyard that looked like that. Now, if you're going to have a big propane tank in your backyard, you might as well give it some style, some pizzazz. Look at that thing. That's cool. There's another one. I've never seen one of those, but there's a propane tank. Butane, used in lighters and portable curling irons. So there's a curling iron. It has no cord. It's got butane in it. It gets hot and curl your hair. There's your Bic lighter. There's another torch. Instead of a propane torch, you could have a butane torch. And here's a ridiculous scenario where somebody's torching their iPhone. Crazy. Ethene is a plant hormone, causes fruit to ripen. It's also used in industry. So here's your fruit. These little ethene beads or ethylene beads make all kinds of plastic. Those containers, that kind of plastic, and many, many other products. And then, of course, there's ethine, which is acetylene. This is the fuel used by welders. If anybody has ever used an oxyacetylene welder, that torch that has two hoses coming into it, tank of oxygen and a tank of acetylene, oxyacetylene. So there's those tanks. There's a guy using the torch. It's used in welding. And this, look at this. This is a result of leaking acetylene bottles stored in a plumber's van. That is the van after the explosion. Looks like it's just been blasted right apart. There's a part of the roof rack that was on the van. There's the side door. So, explosive stuff. Let's talk about cyclic hydrocarbons. Okay. Cyclic means a ring. So we take these straight chains that we've been talking about and we just bend the two ends together and we make a ring, a closed ring. So these are called cycloalkanes. Okay? Now you can also, or cycloalkenes, you can have cycloalkynes, but they don't occur unless we have 8 carbons. Alright. Cycloalkanes, they have the formula CnH to the 2n, and here's the formula for alkenes and for alkynes. They are represented by geometric shapes. What do I mean there? Well, take a look. If I had C5 in a straight line in just an alkane, I would have pentane. I could bend the two ends together. I'd have cyclopentane. And I can show that by drawing a pentagon. And if I draw a pentagon, I know what that is. That's cyclopentane. Okay, that's a cyclo. It has the formula CnH to the 2n. So instead of C5H12, I have C5H10. Alright, so there's what it would look like. There's my 5 carbons. Each carbon has to have 4 bonds. 1, 2, 3, 4. So that carbon has 2 H's, 4 H's, 6, 8, 10. C5H10. Cyclopentane. There's what it would look like with one of those ball and stick models. Okay, so the name is based on the number of carbons. So 5 carbons is pentane. When it's ring-shaped, it's cyclopentane. Okay, next. We follow the parent numbering rules to number the parent. So that's these. So remember, double and triple bonds get priority, then branches, and then we go alphabetically with branches. Isomers, cycloalkanes are isomers of alkenes, and alkenes are isomers of alkynes. Same formula, different structure. And they have slightly higher boiling points because of their more compact structure. Okay, let's move on. So, how would we name this one? Well, it's 3 carbons, propane, ring-shaped, cyclopropane. What would you name that one? That is correct. I would name that cyclooctane. Now you're saying, what about the numbers? Oops. Now you're saying, what about the numbers? Well, you would just start here. 1, 2, 3, 4, 5, 6, 7. So you would always start there, because you would always start there no matter where that triple bond was. It would just be a 1, so we don't even need it. Cyclooctane. Okay, how would you name this one? Correct. This is methyl cyclopentane. Branch, parent. Remember that pattern. Branch, parent, branch, parent. All right, try this one. 2,3 dimethyl. Don't forget the di. We got 2 of those. 2,3 dimethyl. And then cyclopentene. Cyclopentene. Alright, how would you name that one? It's in the way there. What does that say? 2-methyl cyclopentene. How would you draw that? Okay, well, go ahead and try it, and then you can unpause me and check, and also try this one as well. Okay, we're going to do 2-methyl cyclopentene. So here's the parent. Now we know it's 5 carbons, and cyclo means ring-shaped. So I'm going to draw my geometric shape, a pentagon. 1, 2, 3, 4, 5. And I've got cyclopentene. I know it has to be a double bond somewhere. Now I could put it anywhere. I'll just put it here. There's my double bond. Now because that's my double bond, that will be number 1, and this will be carbon number 2 right there. I could have gone the other way. And I know that I have a methyl branch attached to carbon number 2. There we go. Or I could have written it this way. CH3. So there is 2-methyl cyclopentene. There you go. So now we're going to draw this one. There's my parent cyclohexane. Okay, there's my hexagon. Now I know I have 2 methyl branches, and they're attached to carbon 1 and carbon 3. So where's carbon 1? Well, it doesn't matter. You can just pick one. We could say that's carbon 1 and go around this way. We could say that's carbon 1, go around this way. So it doesn't matter. So I'm just going to say that is carbon 1, carbon 2, carbon 3. I could have put them anywhere as long as it was 1, 2, 3 or 1, 2, 3. But 1,3-dimethyl cyclohexane. And there you have it.